The Earth possesses a few exceptional qualities when compared to other planets. It contains water, atmosphere, mild territories, and an even more unusual phenomenon, life, developed into its countless forms. It often seems that this wealth and diversity have always existed on our planet. But this is not the case. Titanic external and internal forces have changed the nature of the Earth many times since its birth. Occasionally, nature reminds us of the existence of these forces and of their devastating effects. Despite these catastrophes, the Earth presents itself as pleasant and stable. However, will it always be like that? How did it all begin? How has the Earth come to be in its current state? What role has life played, in particular, human life? Gaia, the Big Mother. All cultures have worshipped the Earth in one way or another. The Earth is the Big Mother, protective and abundant, the origin of our world. In Greek mythology, the goddess Gaia was the personification of Mother Nature. Here we see her represented in this ceramic. Gaia is delivering to another goddess the child who is destined to become the king of Athens. Arisen from the chaos, Gaia bred first the air and the starry sky. Later, she created the water and the oceans and extended life to the whole planet. Monotheistic religions have modified the myths of antiquity, adding both authority and transcendency. The chronology of the creation of the world is similar. According to the books of Judeo-Christian tradition, God created the universe in 6 days. On the first day, light. The next day, water. On the third day, the earth. Then the stars. Next, the fish, birds, and ground animals. And finally, human beings in God's own image. Attempting to modernize the myth, 17th century Irish Archbishop James Ussher sought to establish the time and date of divine creation. Ussher established that the earth came into being on October the 23rd, 4004 BC. This belief, in its many different forms, has prevailed for centuries and currently prevails for more than half of humanity. However intuitive or encouraging this explanation may be, the reality is quite different. We are in Cap de Creus, at the extreme northeast of Catalonia, a region of great and rugged beauty. Here are a few of the most ancient rocks that have emerged in this country. The earth reveals itself here, raw and natural. Geological diversity, these are rocks of different compositions, contributes to a surprising variety of colors. The painter Salvador Dalí, who was born near here, had this to say about the area. It is a mythological place, which is more for the gods than for men. And it must continue this way forever, without anything that could mystify it. It is pure geology. The air and the water have eroded the territory and have sculpted unlikely forms, some of which served as inspiration for Dali. A rock shaped like a camel, which is approximately 300 million years old. Another that looks like a dromedary. And this, like an eagle. They are all the result of a gradual process in which time has played and continues to play a fundamental role. Here is a scene equally revealing, the so-called Sicker Point, cliffs found in the east of Scotland. In the 18th century, the naturalist James Hutton devoted himself to investigating them. Hutton, of a humanistic education, inherited a few nearby grasslands, which gave him the opportunity to indulge the curiosity he had about the intricate formations of the coast. The investigation brought him to the conclusion that the rocks of these cliffs were the product of a series of very, very slow processes that had developed over a time that could be counted in tens of millions of years. We now know that that number is much higher, but the idea of a geological time greater than human time is crucial to understanding the Earth's evolution. Hutton also thought of the Earth as a living superorganism. Its study would fall to the physiologists who study the functions of living beings. This superorganism was given the name GAIA, as it couldn't be any other way. In modern times, it has become a respected scientific theory. Under the gaze of scientific curiosity, the Earth's rocks reveal its past. Hutton discovered that the history of Earth is not written in any sacred book, but on the Earth itself. It all began with a great explosion, the Big Bang. In an undecipherable instant, time, space, and primordial material appeared. To many scientists, it made no sense asking themselves, what was there before? Because there was neither space nor time. According to Stephen Hawking, the British astrophysicist, that is like asking what lies 5 miles north of the North Pole. During the first minutes of the Big Bang, the first chemical elements, hydrogen, helium, lithium, appeared. Gravity and nuclear energy reigned, and at times this crude matter would come together to form stars. Some of these stars would disintegrate, dispersing new matter. Others gathered together, forming galaxies. Such as our galaxy, the Milky Way. It gathered together hundreds of millions of stars, one of which is our sun. Around that primal sun, some 20 clusters of boiling material called protoplanets formed. Eventually, one of these protoplanets would become the Earth. Repeatedly bombarded by other bodies, it would increase in size. The most gigantic collision, the greatest that has ever occurred, was with a star the size of the planet Mars. The densest part of raw material ended up absorbed by the Earth. The rest became its moon. The star that spawned the moon goes by the name of another goddess, Theia. Theia was in fact Gaia's daughter and the mother of Selene, the moon. Approximately 4,600,000,000 years ago, the Earth and the solar system were formed. But how can we account for such colossal measurements? From the Big Bang to the Big Mother, 9,100,000,000 years passed. So the Earth is approximately 1/3 the age of the universe. Let's imagine a calendar where the birth of the Earth occurs at 0 hours on the 1st of January, and the last instant of the 31st of December is right now our current time. So the 365 days of this particular year represent the 4,600,000,000 years of the history of Earth. Let's pay close attention to this detail. Humanity only occupies the last 5 minutes on December 31st. During the first 600 million years, the Earth was an incandescent mass where meteorites and other cosmic objects rained down constantly. The Moon was close and raised tides across its surface. The size of the planet continued to grow. Later, the rhythm of the rain reduced, and gradually the surface cooled down. This was the beginning of the history of the solid Earth. We are in one of the sites, the newest, of the Natural Sciences Museum of Barcelona. The site hosts exhibitions and promotes outreach activities using modern techniques and ideas. In addition to exhibitions, the museum devotes itself to preserving objects of natural origin, and as such, it also attracts experts. One of the exhibitions is entirely dedicated to the Earth and its history. The itinerary begins with these 2 rocks. The biggest is of volcanic origin. The smaller one is a meteorite, just like those earlier meteorites that fell and will always fall from space. Meteorites adapt varied forms and many different compositions. There is also a remarkable collection of minerals. One of the most valuable is this example of pyromorphite. Both the meteorites and the minerals have the same origin: space. Some are rather ugly, scorched and disfigured from so much roaming, while others, incubated for millions of years underground, seem made to be admired. The charm of these minerals contrasts with the environment of their origin, when the Earth was first beginning to solidify. The Earth was an extremely desolated planet. Many landscapes must have been like those that currently exist on the planet Mars. This period is known as Hadean, named after Hades, the Greek god, another of Gaia's grandchildren who presided over the world of the dead. But every now and then, the Earth seemed to become furious. This is Vesuvius, the only active volcano remaining in continental Europe. At its feet, the city of Naples seems indifferent to the latent danger of the volcano, which has roared some 20 times in human memory. The most well-known eruption, and the most harmful one, took place in the year 79 of our age. In the 18th century, the French painter Pierre-Jacques Vollert represented it in this way. Clouds of poisonous gases and incandescent particles, as well as rivers of lava, devastated a good part of the territory, and in particular the city of Pompeii. Its inhabitants remained trapped by the ash and by history. Pliny the Younger, a Roman historian, was an eyewitness to the event. He said, "When clarity began to return, the bodies were intact, untouched, dressed as they had been. By their look, they appeared asleep rather than dead." These bodies represent only a fraction of the horror faced when nature is unleashed. The interior of the Earth is like an onion. It is made of layers that differ in composition and dynamics. The Earth's core consists of very dense material made up of iron and nickel at a temperature of around 7,000 degrees Celsius. Above this, there are a series of layers of gradually lower temperatures and densities. At the top, there is a rigid crust from 5 to 60 kilometers thick, which floats on a mantle that has a plastic-like consistency. The Earth's crust is not a uniform layer. It is fragmented into large plates called tectonic plates that move slowly upon the mantle. In a volcano, molten materials erupt from inside the Earth to its surface. Rivers of lava become rocks when cooled. Over time, the disintegration of these rocks can result in fertile ground. The distribution of volcanoes on the planet follows a recognizable pattern. Consistent with the profiles of some continents, the same distribution as the tectonic plates. Obviously, this coincidence is not an accident. In moving, some plates have separated from each other. The North American and the Eurasian plates, for example, move about 7 centimeters further apart from each other every year. It seems very little, but it is sufficient that in geological time, the distribution of the continents has completely changed several times. When they collide, the densest plate goes below the lighter one, resulting in an elevated border. This is how great mountain ranges were formed: the Pyrenees, the Alps, the Andes, the Himalayas. Another consequence of the movement of tectonic plates is earthquakes, one of the most potentially destructive natural phenomena. Every year, millions of earthquakes occur, yet most of them pass by unnoticed. Some 600 million years after its birth, the Earth's mass was more or less as it is now, as were the basic dynamics that defined it. From space, comets, meteorites, radiation, or from its interior, the movement of tectonic plates. However, it would take much longer for life to appear. An essential element was absent: water. Almost 3/4 of the planet's surface is covered with water. As the English writer Arthur C. Clarke said, "How inappropriate to call this planet Earth when it is clearly ocean." 98% of the water that exists on Earth is in the oceans. Therefore, it is salt water. The rest, our valuable fresh water, is partly underground. There is also water held at the poles and in the glaciers, floating in the clouds, and in the bodies of living beings. 65% of a person's body is water. All known life depends on it. For life to exist at all, the Earth needs to be at a certain distance from the sun. Too close, and the water would evaporate. Too far, and it would freeze. Not only that, an atmosphere is necessary for water to be retained. These were the conditions a few billion years after the Earth's origin. There was an atmosphere that was basically composed of methane and carbon dioxide gas. But where did water come from? For a time, the Earth experienced an exceptionally heavy rainfall of external bodies. It is believed that the water came embedded in those meteorites in molecular form. However, the theory has not yet been proven, despite it being one of the major goals of space exploration. In a relatively short time, the Earth was flooded. Today, the oceans contain almost the same volume of water as that of that first global ocean, only its distribution has changed. Submerged volcanoes on the borders of the plates were generating islands in the middle of the ocean. Little by little, these islands came together to form bigger territories. The remains of one of these islands can be found in Greenland. It is one of the oldest parts of the continent that exists in the current era. It was already in existence when from beneath the depth of the oceans, the spark of life came. A combination of water, heat, and gases emitted by volcanoes, along with complex molecules, led to life. The molecules are thought to have arrived on board the raining meteorites, but this is an even more difficult theory to prove. The first single-celled organisms were called cyanobacteria, also known as blue-green algae. The green comes from the chlorophyll that they contain, which allows them to obtain nourishment through photosynthesis. The combination of carbon dioxide with the light's energy produces carbohydrates and gives off oxygen. Over time, the success of the procedure will spread across the whole planet. And it has permitted the survival of the cyanobacteria almost as if evolution had nothing to do with them. Cyanobacteria are everywhere. In the oceans, they are the primary producers of phytoplankton, which feed many marine animals. They can also be found in freshwater, in Antarctic rocks, and even in humid desert rocks. We are in the Diocesan Seminar of Barcelona, a place that, in addition to being home to religious activities, houses an interesting museum of geology. This place is dominated by the idea of a supreme creator, but the scientific account of the Earth's history is openly displayed in this museum, regardless of whether we call the source of it all God, or we call it Big Bang. As a matter of fact, one of the fathers of the Big Bang idea was the Belgian priest Georges Lemaitre. Lemaitre saw no inconsistency in being religious and scientific at the same time. He said, if a believer wants to swim, it is better to do so as a non-believer. Likewise, if a believer wants to practice science, one must do so as a non-believer. The museum contains a valuable collection of holotypes. An holotype is a fossil type that is used to describe each new species which is discovered. The holotype category of a fossil is assigned by the international community of paleontologists. The museum also contains tens of thousands of fossils from various geological periods, patiently collected since the 19th century. The most valuable item here is this example of Ediacara biota, the most ancient multicellular organism ever known. A long time passed between the emergence of the first single-celled organisms and these multicellular ones. Nobody can explain the extreme slowness of this very first stage of life's evolution. Certainly, there have been attempts to do so over time, but they have either been proven false or they were not recorded at all. Later, the first creatures with hard parts appeared, shells, spines, skeletons, to protect specialized organs and allowed them better movement. In a relatively short geological time, the ocean filled with increasingly complex creatures. And the tree of life branched out in all directions. Life was to be yet another cause of the Earth's transformation. This first became apparent when the minuscule cyanobacteria were dominant. They came to emit so much oxygen that the atmosphere turned lethal, which provoked the glaciation of the planet and the extinction of numerous primitive species. Later, other global glaciations took place. The planet resulting from these glaciations was christened the Snowball by geologists. Icy periods have alternated with tropical periods. In fact, tropical periods have been predominant. One of these was to cause a colossal catastrophe. We are on the coast of the Basque Country, next to the village of Zumaia. The area is designated as a geopark, a protected and organized natural environment for the enjoyment of visitors and, in particular, for geologists. The cliffs reveal a 60 million year history. The hard layers alternate with soft layers of sediment, all of which originate from the depths of the sea. Once buried and transformed into rocks, they were displaced by the internal dynamics of the Earth, mainly when the Pyrenees were emerging. The rocks continued to rise until they remained exposed to the erosion of the sea. Some of them rise up vertically, and, facing each other, they seem to form the pages of a book about the Earth's history. Each slice or each page represents the course of a few million years from an extremely distant past. It is no surprise that this place attracts the attention of geologists from all over the world. In a recess, we can see a blackened layer which reveals a very significant event. It is the indication of a gigantic meteorite fall which had consequences for the whole planet about 65 million years ago. On hitting the Earth, the meteorite produced a crater kilometers wide and raised a trail of dust and gases which darkened the planet for years. Most of terrestrial and marine species disappeared. Among them, the dominant group of animals of the age, the dinosaurs. But there have been other extinctions much more catastrophic than this one. Geologists refer to the 5 most important as the Big Five. Overall, mass extinctions have resulted in the death of 90% of all the species that have ever emerged. The only species that has survived them all is the humble cyanobacteria. The dinosaurs were the culmination of a long evolutionary chain that began with the first chordates and fish in the ocean and the vegetation on the continent. When the atmosphere was dense enough and the ozone layer sufficiently large to reflect lethal solar radiation, life was established on Earth. Before long, the reptiles became the masters of it. Their formula for success? A great capacity to adapt to the environment and increasing physical strength. The most ferocious reptiles, carnivorous dinosaurs, would eventually reign supreme at the head of the pyramid of predators. Birds are their descendants. In the absence of dinosaurs, mammals, one of those species that had resisted extinction, progressed rapidly. Meanwhile, far below, tectonic plates continued their dance. In time, they formed a single large fragmenting continent called Pangaea. First, Pangaea split into 2 continents. From a bird's eye view, the color green would have predominated. There were no polar ice caps. In time, the Atlantic Ocean opened up completely. Finally, oceans, continents, and the tectonic plates remain distributed roughly as they are today. The cradle for a very singular species was almost ready. In Central Africa, a few mammals were already beginning to stand upright, on two legs, and were becoming aware. The first hominid was Homo erectus. Of his progeny, the only subspecies that survived was Homo sapiens. About 70,000 years ago, a group of Homo sapiens, driven by hunger or curiosity, started walking to the northeast. First, they stepped on the Middle East. The Red Sea was narrower than it is today, and they then came to Asia. Crossing the Bering Strait, which was frozen, they reached America. Recent studies indicate that the whole of current humanity is descended from about 200 individuals who stepped out of Africa. Technological man, who communicates by means of language and who even paints, scarcely occupies the last 2 minutes of our calendar year. We are at the GAIA Museum and the GAIA Mines Archaeological Park. The building evokes the image of the same hut found on any archaeological excavation in the world. Here, there are a set of structured mines with the oldest galleries ever discovered in Europe. Excavations are still taking place, and occasionally, new galleries are discovered. For over 1,000 years, variscite, a greenish mineral that was used in creating jewelry and offered in exchange for other goods, was extracted. When a sector of a gallery was abandoned, it was used as landfill. From these landfills, various items were recovered. There are the remains of burials, everyday objects, tools, and jewelry, like this necklace made of pieces of variscite. The most valuable item in the museum is this Venus, one of the few religious figures preserved from the Neolithic age. This female figure, another mother, represents fertility and the fertility of the soil. Mineral extraction, to which this evocative museum is dedicated, was then the only interesting thing that came from below the ground. Scientific interest would appear much later. During the Renaissance, just 6 seconds ago on the calendar, when everything seemed tailor-made for man, Leonardo da Vinci was dedicated to studying landscapes with an artistic and at the same time scientific eye. This made him wonder about what was hidden below the ground. Leonardo was obsessed with water. Leonardo's final paintings are disturbing depictions of floods and storms. He thought the erosion he observed in landscapes was caused by water, a water which was being recycled thanks to a type of underground system of veins. Believing water to be to the world what blood is to our bodies. The large-scale exploitation of the subsoil began with the Industrial Revolution 3 seconds ago. Coal was fuel, and the need for it became essential. The contributions of the first geologists were, then, decisive. In 1830, Charles Lyell, another Scottish naturalist, published the book Principles of Geology, which takes up and develops the ideas of his compatriot James Hutton. Lyell wrote, "The present is the key to the past." A few years later, the English biologist Charles Darwin published another landmark book, On the Origin of Species, which laid the foundation of evolutionary theory. Darwin acknowledged that Lyell's book had a powerful impact on him. The theories discussed in the two books have a common denominator: geological time. Another significant contribution to geology and archaeology is the absolute dating techniques discovered in the 20th century, which allow scientists to calculate the age of material from the past. They rely on the fact that certain chemical elements, such as carbon-14, decays at a known rate. Therefore, knowing the proportion in an object, the amount of time that has elapsed can be deduced. Like an hourglass where we know the amount of sand that has fallen, we know how much there was at the beginning. In such a way, the history of the Earth is written in the Earth itself, as Hutton said, and furthermore, the dates of the events are indicated on the pages of this book. We are on the Dover coast in the south of England. Here rise formidable cliffs made of a very fine calcium, a kind of plaster, a sediment formed from the remains of single-celled animals. As a result of erosion, this material has become worn and crumbles at a rate of 1 centimeter a year, although occasionally very large blocks shear off and fall into the sea. This site has important symbolic value for English people. The white cliffs were like fortresses against the invaders who threatened the island. They currently surround a major port and a bustling city, presided over by those defensive constructions of yesteryear. Under the sea can be found the same white, waterproof and easy-to-dig material, which affords a significant advantage when it comes to piercing the rock. For this reason, the tunnel that connects England and France was built here. It is one of the longest underwater tunnels in the world. One of history's ironies. The same material which rose up so impressively to fend off invaders now permits easy access from below. The Channel Tunnel is a work that is representative of the advances in applied geology, but there are many more. The pick and shovel have given way to huge tunneling machines and transports. If outer space is limitless, so is the space below ground. Today, the most exploited underground product is oil. Modern societies depend on it in a way that is considered to be excessive because of the side effects involved in obtaining it. The resulting gases from the massive burning of fossil fuels enter the atmosphere and create a layer that retains the heat. Then, a greenhouse effect makes the temperature rise. Everything is connected. This increase in temperature might result in a change in the circulation of the oceanic currents and, as a consequence, a climactic change similar to a glaciation of half of the planet may occur. Another consequence of this thermal increase is the fusion of the frozen soil found in the Siberian permafrost. When melting, permafrost often violently liberates enormous quantities of methane, a greenhouse gas. More and more, explosions of this type are being detected. Dependency on fossil fuels could also have repercussions for the Earth's interior. For example, in a recent technique known as fracking, where water at high pressure is pumped into the subsoil so that it expels the gas that it contains. However, it is not yet clear if the Earth's subsoil can be squeezed like a sponge without consequences. The fact is that the evidence of climactic and geological changes as a result of human activity is accumulating. Dinosaurs took a few of our calendar days to evolve and become the first terrestrial predators. So far, the fragile mammal has been at the top of the pyramid for only 2 minutes and seems intent on plundering everything which is of use to it from under the ground. It has been 4,600,000,000 years since the Earth was born. At present, it is in a period of good weather. But how will it evolve? The fate of Earth is linked to the Sun. The Sun is approximately halfway through its life. In about 5 billion years, when it runs out of fuel, the Sun will swell up and it will gobble up the whole solar system. It will turn into a giant red star and end up as a giant white dwarf of dust. The Earth will have disappeared hundreds of millions of years before this happens. So the Earth is also more or less in the middle of its history. Thus, its geological time will run for another 4,600,000,000 years. The movement of the tectonic plates will continue to redistribute continents. The Atlantic Ocean will be as big as the Pacific Ocean. The Mediterranean will end up closing, and a new mountain range similar to the Himalayas will take shape. The continents will eventually coalesce into a single platform, a new Pangaea. Meanwhile, new volcanoes will rise, the ground will tremble, meteorites will rain down, climates will change. New catastrophes will once again cause the extinction of most species. Among the few that survive will very likely be the cyanobacteria, waiting for a new opportunity to restart the history of life. In the end, the Earth will be as it began, an incandescent mass containing the atoms that were part of every human being who ever inhabited it. But this view is too far into the future for a person, the life of whom occupies only half a second of the calendar. What can you expect to happen in human time, the time of people and cities? We are in Barcelona. This is the head office of the Institut Cartogràfic i Geològic de Catalunya, the public institution dedicated to studying and mapping the Catalan territory. The entrance is presided over by several maps. This is the geological map of Catalonia. It shows different types of rocks and the types of links between them. It also shows the tectonic structures, folds and faults, the fossil deposits, the mineral resources. Geological maps are drawn based on topographical maps, to which the field research is added. This is the room of the institute where earthquakes are monitored, the heartbeat of the Earth. A network of measurement stations, one of which is under the sea, detects all seismic activity. It is very difficult to predict earthquakes by studying them, but maybe one day this will be possible. Geological catastrophes cannot be stopped, but their effects could be mitigated. Predictable possible threats are comets, asteroids, and other bodies that come from space. With these, the problem is that they can only be observed if they are close enough, so there might be a little time to react. There are currently astronomical observation programs exclusively dedicated to watching out for them. The threats most likely to affect a person's life are those that originate from human activity. For some experts, global warming as a result of human activity will lead to a period similar to that known as the sixth extinction. In any case, it seems that the time needed to stop global warming has run out. The Earth is the result of a succession of infernal cycles of destruction and resurgence. Meteorites have opened very deep wounds, yet at the same time they have brought water and the seeds of life. In human time, the fire of the volcanoes causes everything to crumble, but in geological time, this has empowered life. Between apparent contradictions, the history of the Earth seems to point in a direction which favors the advancement of life. There are more signs that invite us to think about this. For example, the different densities of the Earth's interior that cause the planet to spin like a top, resulting in the natural cycle of the seasons, crucial for many living things. Another distinctive feature of the Earth: there is a magnetic field surrounding it that shields it from lethal solar radiation. This magnetic field is produced by the abundance of iron that exists in its core, which rotates lubricated by the external core. Without this shield, life might not exist. It is even said that the extraordinary geological and biological diversity of the Earth exists to attract the attention of an awakened mind. Certainly, without the colors of nature, there would be no art. And without a transparent atmosphere, scientific curiosity would not have awakened. That is why there are those who believe that the superorganism GAIA, if it can be called that, has a mission: to shelter life, in particular, intelligent life. The fact is that this privileged planet shows symptoms of an imbalance caused by the supposedly intelligent life within it. We do not know the consequences of this imbalance, and perhaps when they are known, it will already be too late. Future generations have the same right as us to inhabit a healthy planet. That's why it is necessary for us to be more aware of geological time. Additionally, the sustainability and biodiversity of the planet should be valuable assets within the logic of the markets. For Mother and for Big, the Earth deserves our respect.